Yeah.
A very warm and pleasant good morning to one and all present here. Respected chief guest, distinguished keynote speakers, eminent researchers, faculty members, delegates, and my dear participants. It is my great privilege and honor to welcome you all the second day of IEEE conference, a platform that continues to foster innovation, scholarly exchange, and technological advancement. After the intellectually enriching deliberation of yesterday, we assemble once again with renewed enthusiasm and curiosity to explore deeper dimension of research and emerging technologies. I would like to welcome our guest, Dr. Professor Rajesh Kumar Tiwari, Principal of ICRTCST College, Dr. Professor Prabhachan, Professor Dr. Veer Pratap Meena, and Dr. Dilip Kumar Yadav, Professor Mahmood Alam, and Dr. Sorry, sir. Professor Dr. Priyadesi Jagwar, sir. IVSCT College welcomes you all, sir. Now I would like to request Principal, sir, to do the honor by presenting sapling to Dr. Veer Pratap Meena.
फ्रंट पे जाइए और सामने जाइए. सामने जाने को सामने नहीं जा रहा.
Now I would like to request Dr. Prabhachan.
सामने जाइए ना.
Now I would like to request Professor Dr. Priyadesi Jagwar, sir. Now I would like to request Dr. Vikram Sarma, sir, to present a sapling to Professor Dr. Mahmood Alam, sir. Thank you, sir. As we know that education is a journey which offers wisdom and motivation to keep you moving forward. Looking with this, now it's a time for the presentation. So I would like to request Professor Prabhachan to give her valuable presentation in front.
Okay, wait. You want presentation? Prior to that. I'm sorry. Good morning, everyone. It's an honor for me that we have professors, a team of professors. First, Principal Director of GGST, Professor Priyadarshi Jarwar sir. Professor Dr. Prabhachan ma'am from NIT Jamshedpur, Professor Meena from NIT Jamshedpur, Professor Mahmood Alam from GGST, all the faculty members of RVS and students. So this is the second day and the first technical session. Before we start the keynote speech of Professor Professor ma'am from NIT Jamshedpur, I will request the director of GGST to just give a brief blessings to all the students, all the participants, all the authors, all the faculty members of RVS. Sir, please.
Good morning, everyone present over here. Respected Dr. Tiwari sir, Principal RVS Engineering College, professors on the dais, eminent personalities, head of departments, scientists, and my dear young students. I congratulate first of all to the institution that it has conducted an international level IEEE conference. It is of a very prestigious nature in our academic and scientific fraternity, and I also congratulate personally my friend, colleague, Dr. Tiwari sir, that yesterday His Excellency Governor of Jharkhand also inaugurated this function. So, my dear students, this is your time. Now world is moving towards technology, science, engineering, and for that this conference was meant for. So what is the role of an engineer or a scientist? Role is basically to make life more comfortable, more easy, and more secure. And for that, the basic study of engineering, science, basic principles are very important. I hope that you were part of that program, and you will be the part of this program very seriously. And in the future, I look into the matter, and I propose also to your institute that we can do many things with hand-holding, with collaboration. Now this world is going to see the success in collaboration, corporations, and corporate world. So once you are able to collaborate, cooperate, then you will also able to invite corporate world, and where your contributions are awaited. Thank you very much. Jai Hind, Jai Jharkhand.
Thank you, sir, for your valuable words. Now, I would like to request our principal sir to do the honor by presenting shawl and memento to Professor Dr. Gangwar Priyadarshi Jog. Sorry, sir. Sorry, sir. Director, GGSESTC. Now I would like to request Sir, right now I would like to take your correct name, sir. Dr. Priyadarshi Jaguar. Now I would like to request Dr. Shalini Kumari to present shawl and memento to Professor Prabhachan and Dr. Surbi Kumari. Thank you, ma'am.
They are the convener of this function.
Now I would like to request Professor Amit Kumar Sinha and Murari sir to present a shawl and memento to Dr. Veer Pratap Meera. Now I would like to request Professor Mahmood Alam sir to come up on the stage, and now Dr. Vikram Sharma sir, please do an honor by presenting memento to him. Thank you, sir. Thank you. Before moving further to our session, we are privileged to welcome Professor Prabhachan, Professor, Department of Mechanical Engineering, NIT Jamshedpur. With over 25 years of experience, his expertise in solar engineering, aerodynamics, thermal engineering, and clean, sustainable engineering technologies greatly enriches the academic strength of this conference. So I would like to request now Professor Prabhachan to give her valuable presentation, and the topic of her presentation is Application of AI in Mechanical Engineering.
तो बैनर लगा था ना? बाहर का आवाज़ क्यों आ रहा है इसमें? हाँ, इस आवाज़ तो बंद हो
Hello.
कहाँ? वहाँ जो वहाँ से जब आया है यहाँ तक। हाँ हाँ, इसलिए तो बोल रहा हूँ क्या किया है वहाँ पे।
Good morning to one and all present here. First of all, I would like to thank Tiwari sir for inviting me here in the IEEE and all the dignitaries from all over the department and your department.
कैसे में लाइट नहीं
All
है?
of you. And myself, Professor Prabhachar from Mechanical Engineering Department in ICRTCST. I am glad to be here and I am going to present just few slides regarding application of AI in mechanical engineering. Because I am basically from mechanical engineering background and when Professor Tiwari asked
लाइट
me
बंद करके आना भाई,
to come here
वो वाला साइड वाला
in
लाइट।
IEEE conference basis, basic theme of this is AI in computer science engineering. I said what I can do here. But as nowadays we are all moving towards AI application and we can't left behind that. So it's my privilege to be here and interacting with you all. Thank you. So first of all, I can say that outline of this presentation is just a brief introduction, and we will go through all these cases one by one. And first of all, I can say that we are now all familiar with the AI term, that means artificial intelligence. So application of AI in mechanical engineering, what we are doing, basically we know that AI by AI, that means artificial intelligence, is the capacity of the machine doing with respect to human intelligence, and we are utilizing it to help us in doing different repetitive work or in a taking the risk and doing in such a way that we can get at prior basis the result that we are getting after repetitive experimentation and simulation like that. So basically mechanical engineering is divided into two categories. First is design and the other is thermal engineering. So how we are using AI in design prospect, that means it reducing the human error rate through algorithm based decision making, and second part is
A risk transfer from people to AI for risk, high risk occupation like Mars and computation. And third is continuous operation, that means machines work 24 hours a day, 7 days in a week, but we can't do that. And next is automation of repetitive and boring tasks to release human creativity, and digital use via highly developed digital assistant and chatbots. And lastly, the faster decision making compared to human emotional and actual analysis. That is the main important part which we don't have in the AI tools. So what challenges and disadvantages we are facing in this, that is high creation cost is the main factor, because hardware and software must satisfy the recent needs. And second is the creating human laziness through dependency on the automated labor, because nowadays we are using Siri and Alaska. Whenever we need, we just tell Alaska, close the door, close the television, close the light, like that. So this creates the human laziness. Rising employment as AI replaces repetitive works and low skilled workers. Like we have nowadays all the equipments we are using in household and in the factory also that are related to the AI. For the cleaning purpose, we have AI generated machines that wherever we are, we can just program it and feed it, clean the house. They are cleaning the house. So this is the main purpose, that means low skilled worker we are replacing with the machine. And what is the lagging in this AI machine, AI generated machine? That means absence of emotion. That is the main drawbacks or disadvantage, we can say that. And machines cannot replace human relationship. Another is the lack of thinking system and only capable of jobs they were programmed for. Another than this programming, it cannot do any job. So programming tools for AI are we are using nowadays is Python, C++, R, Java. So these we are familiar with all these programming tools, and the software we are using different companies like ANSYS, MATLAB and Simulink, Resolve Systems, Siemens and the Altair. So case studies in product design, we are using this AI for the aircraft system, 3D reconstruction and the blueprint design. So all these subjects we are dealing with the AI case in the product design of this with AI help. Another case we are taking as in thermal. So in thermal, we can use this artificial intelligence in phase change material application part. So what we are doing in phase change material we are using for the taking the latent heat of the system, and then solidification and liquefaction is the main part of this phase change material. And PCM stores or releases thermal energy through a reversible solid liquid transition, exploring the high enthalpy of fusion while maintaining near isothermal operations. So this is the main fundamental properties of the phase change material. It may be wax or it may be iron or different kinds of material we are using for this. And the strategic deployment sector where we can use this, that is the key domains include large scale thermal storage for renewable integration, thermal regulation of high power batteries, solar thermal collectors, and passive climate control in building envelopes. And what are the main basic obstacles for using this? That is the phase change process couples non-linear thermophysical properties with moving boundaries conditions, producing multi-stage heat transfer phenomena that are difficult to capture analytically. That's why we are going for the AI tools to generate the simulation process. So motivation for embedding AI in PCM system is experimental bottlenecks. That means comprehensive thermophysical screening demands extensive sample preparation calorimetry, and the cycling testing, often stretching over weeks per material variant. So this is the main purpose. By using the tool, we can get the result in a short period. Simulation overheads, high fidelity CFD models that resolve phase front dynamics consumes massive computational resources, limiting design space exploration to a handful of cases. And third is AI enables accelerators, that means machine learning surrogates can infer complex probability relationship from modest data sets, delivering near instantaneous prediction and enabling closed loop optimization. So these are the main motivation behind the AI tools. Another is AI for nano enhanced PCM design. Basically, nanoparticles, when we are using in the PCM, that it enhances the heat retaining capacity for the cooling purposes. So optimizing particle characteristics to boost heat transfer while preserving stability. So for this, design variable landscape is the main part, that means incorporates nanofiller types. Nanoparticles may be metallic, carbon-based oxides, and dimension scale is 10 to 500 micrometers, and volumetric loading, each affecting interfacial thermal resistance and rheology. And second is the predictive performance metrics, that means models forecast improvement in effective conductivity, access nanocomposite colloidal stability, and quantify the accompanying rise in viscosity that may impede infiltration in confined geometries. So with this, what is the multi-objective optimization framework, and that is the employs evolutionary algorithm guided by AI surrogates to simultaneously minimize experimental iterations and maximize the weighted score of thermal gain versus processability. So these are the AI-based phase change process forecasting, temporal evolution modeling, application scenarios, and network architecture. So by this, we can enhance the battery thermal management system also. In battery thermal management system, what we are doing, the battery which are using in electric vehicles, we are trying to enhance the heat capacity, transfer the heat generated during the combustion process or using process of this battery to PCM. So by this cooling of the battery, we are doing by in BTMS system. So first is the predictive thermal mapping, that means AI models ingest real-time operating data, that means current voltage, ambient temperature, and output cell level temperature forecast, accounting for PCM phase dynamics. And second is the geometric and operational optimization, that means design variables include PCM, placement topology, layer thickness, enclosure geometry, and charge discharge spacing, all jointly tuned to platinum temperature peaks. So by this, nanomaterials with PCM we are utilizing in this configuration to enhance the capacity or the cooling effect of the battery. Adaptive control loop, that means integrates the predictor with a supervisory controller that modulates cooling intensity or charging current, creating a self-regulating BTMS that prolongs cycle life and enhances the safety. So these are the AI-assisted CFD and surrogate modeling. In this surrogate modeling pipelines, that means high-resolution CFD runs through the ANSYS and console, populates a training database, a deep neural network, learns the mapping from design parameters to temperature fields, creating an on-demand emulators. And what is the real-time interface capability? That means once trained, the surrogate delivers temperature prediction in milliseconds, enabling rapid what-if analysis and iterative optimization without rerunning expensive simulations. And third is the digital twin realizations. Coupling the surrogate with sensor strings aids a live virtual replica of the PCM system, supporting prediction, maintenance, and performance tuning throughout its operational lives. So with this, we have strategic benefits of AI-empowered PCM engineering. That means it increases the economic efficiency, substitutes dozens of lab trials and high-performance simulations with a handful of model emulations, slashing R&D expenditure. And accelerated design cadence enables engineers to iterate through thousands of material system combination within a single workday, compressing product to market timelines. And third is the elevated predictive fidelity hybrid AI physics models capture subtle null linearities missed by the empirical correlations, delivering higher confidence in performance forecast. And the last one, second last is autonomous multi-objective optimization through algorithm frameworks, balance competing goals, thermal efficiency, material cost, manufacturability without manual supervision. So this is the main advantage, and the sustainable energy advancement by expediting the adoption of high density thermal storage, all fosters great labor renewable integration and reduces reliance on fossil fuel based peaking plants. So by this we can say that this impact synopsis of this is AI has demonstrably accelerated material selection, design optimization and system level integration for PCM technology, delivering high performance with fewer resources. And the next is emerging research directions, deep generative models for inverse PCM synthesis, reinforcement learning driven real-time thermal control and co-design of PCM with additive manufacturing heat exchangers. And the last is IoT-enabled smart energy networks. That means embedding AI augmented PCM module within sensor-rich IoT infrastructures will facilitate predictive load balancing, demand response, and the resilient microgrid operations. Thank you so much.
So, the students here right now, how many students are there? First year? Third semester? So, if you have any question related to this topic, I think all related to mechanical and AI is a very common topic right now. Nowadays, it is much in vogue. All of we are talking about the artificial intelligence day by day. So, the madam has given a great work regarding how AI can be utilized and can be used as an automating the mechanical works, mechanical research work. So all the students, I think you have listened very carefully. So if you have any question regarding this one, you can ask. The student, I'm asking all the students. If you have any question, you please ask. Stand and ask. Madam is there to solve, to give all the queries and inquiries, whatever you have. Just on the behalf of the students now. I'm Dr. Vikram, head training specialist to this college. Just I wanted to know that, yes, AI has given an edge over to whatever we are doing conventionally in research in mechanical, electrical, electronics, and even in basic science, physics, science, chemistry, and everyone. But right now, what are the core AI technologies which you have utilized for this PCM engineering? We have different models, we have different patterns, we have different protocols of AI. So right now, just wanted to know that what are the different models, because right now engineering students are sitting here and the teachers are also there. So what they will be using regarding this research or the research in mechanical, what are the basic competitive technologies of AI which is very much in vogue and which is very much in hand we can use in this type of research work?
Right now, as is 25 years for the solution process, for all the PCM based or for the polling purposes we are using, and all the simulations we are doing through the SS25. And then before experimentation, after literature survey, we are getting just approximation of the result through the AI tools. And then in our library also we have AI generated software, that means for the literature survey, and at a time you can get all the review papers on the specific topic. So we can get through AI all the literature survey which we are going through, taking it months or 2 months or 3 months like that time, and we are getting that within 1 week from the AI tools for the literature survey also. So that is the advantage we are getting at NIT Jamshedpur, and all the experimentation, all the lab facility we have, that we are using for. So we in the computer also, computer science department also, AI ML lab also we have, IoT lab is there. So we are using all that software to for the optimization testing. Thanks.
Actually, we have the chatbots available in the AI boxes. So just type down the prompt and finally everything will be settled down, will be precipitated immediately within 5 to 10 minutes. So, is that enough or something else is required?
But we can't 100% rely on that results we are getting from the chatbot. So we are finally getting it through the experimental validation and all that we are doing. This software.
Any questions from anyone? If you have any questions from anyone, any teachers, if you want ask some questions. No. Because right now the availability is only with us. That is, we have the chatbots. Either the Google Gemini is available or Group is available. This type of things are available. And we have one box and we have the prompt in our mind. We are framing the prompt and finally we are typing it. And after that, as you have said that this is an AI empowered PCM engineering. So we have the teachers in electronics and electrical. How can they utilize those AI? AI empowered. What may be the topics if they can?
Actually, we have formed a collaborative research lab and group of faculties. That means we have a research group. That means we are integrating the mechanical engineering problems with the electronics and computer science, and all we are sharing the
Same
problem,
yes.
and then solving what is the best method to solve our problem. So that is the advantage, and that's why we are getting this central research facility. And we are all heavy equipment, all the equipment we are centralized, so that we all departments can utilize that and by that helping each other. Because all mechanical people are not aware with these tools also.
Right
So
now,
we are just taking that.
the AI is in nascent stage.
Yeah.
It's not native. I'm not saying it's native, but it is in nascent.
Yeah.
And whatever the promised priorities the AI has promised us, still AI is not giving us.
Not giving, yeah.
So now the question is that AI, that we are holding AI in our hand, or AI is holding us in his hand.
We are holding AI in our hand.
That is the main question, that
Yes,
AI that is holding. So we are in the hand of AI or AI is in the hand of us?
We are making use of AI, but we are not use myself for the AI. That is the
Okay. Thank you, ma'am. Thank you so much.
Thank you.
Have a good one.
Nowadays, everywhere is AI, AI, AI. From the morning till the night, AI. Education breeds confidence, confidence breeds hopes, and hope breeds peace. Looking this forward, now our next session is online, and Professor, online Kunal? Online session, Professor Sanjay, Mechanical Department from NIT Jamshedpur. Please connect it, Kunal. 12:05.
12:15, ma'am.
12:30.
Yes, ma'am.
So
12:13 or 12:15?
15.
1:5, no?
Yes, sir.
So 12:15, 12:15.
okay, fine. As it's set it by this time.
So we are only 20 minutes.
Yeah. So what to do next is that
सर
is
कॉल कर लिया जाए सर क्योंकि if sir is available in so we are also available to listen sir.
we come to the next session.
Let us off Sanjay sir. If he is available then we will start Sanjay sir then.
तो मैंने
So good morning everyone and a warm welcome from RVS College of Engineering and Technology Jamshedpur to all our esteemed guests, dignitaries and especially for the madam, her distinguished and aristocratic presence at RVS campus today for the keynote speech. Thank you so much. The brief and the insights really helped us. This is a purposeful event regarding, that's why I'm not the man of mechanical, I'm the man of chemistry, but still I'm very much interested in these type of topics where AI is involved in the research and this type of topics where the AI is playing the part where the current generation is working very fast. Nearly, I have been looking all the topics regarding the AI, which is really interested and the purposeful and the insightful regarding that. I keep on hearing the different the CEOs regarding the AI, what they are saying. Because I am in a talent management right now. I am managing the industry, I am managing the people, I am managing the students regarding the jobs and job creation. So that's why I really, it's a mesmerizing for me and really it's a different topic for me that the AI has started. I just said that AI is not naive, but AI is nascent. It's a very initial stage. And the CEOs are and the company people are saying that in a very current, the AI will rise like anything and it will take away the jobs of the people. Because right now the industries have already started taking the help of the AI and all the researchers like you ma'am, they have also taken the help of taking the benefits of the AI. So whatever the deliveries AI is giving to us, the delivery is one thing and the promise is one thing. If I promise A, we cannot deliver B. There should be a congestion between the convergence between the delivery and the promise. Right now, whatever the delivery we are getting and whatever the promises we have already heard from the different companies and different researchers and the different educationists, there is a vast difference between these two. There is a widened gap between these two. But really in the near future, within 5 to 6 years, that's why I'm saying always to my dear student that please keep cope with the AI, please keep cope with the current trends, what is happening in the industry, which is what is going inside the industry. Right now, you may be the engineering students of mechanical, you may be electronics engineer or electrical engineer. Everywhere there is AI, even in environment. I'm just searching tomorrow's. Today I was searching regarding the environment, how we can assemble AI in environment. How can I do AI and what are the different required and the assistance the AI can give us in the environmental study. And right away the AI is everywhere. It is an omnipresent. AI is doing everything. All starting from the scratch to the pillars. Everything AI is doing. So that's why I request all the students, whatever the speakers are providing you right now, whatever the education, whatever the topics which they are providing you, the insights they are providing you, you please listen very carefully. The madam is there to solve all the queries. Still she is with us. Again we have the right away many the great scientists and the professors available who will be providing you the great insights regarding the AI and AI chatbots. But we only know the Google Gemini, we only know about the different groups and different AI chatbots. But the main thing is, what is the AI models? What is the AI infrastructure? We know that there are the 5 layers of AI infrastructures. I'm not the man of this one, but still I'm very much interested in knowing this type of AI infrastructure, that is the energy, chip, cloud, models and applications. These are the 5 infrastructures, and our country is working very fastly over this. Whatever the priorities we have the priority of energy, we have the priority of chip, we have the priority of energy, we have the priority of models, and we have the priority of applications. We are only thinking about the applications, we are not concerned about the energy, we are not concerned about the chips. Yes, our country and our scientists are working very hard over the conservation of energy, over the conservation of chips. Different industries are being set up regarding the chip formation and the graduation of them. But your part, the student of engineering part, is that you have to read all the 5 structures, 5 infrastructures, 5 models, 5 layers of the AI. And we have today, this conference is going on, IEEE, and this is basically related to the AI. How AI is helping us, how AI is helping the society, how AI is helping the student, how AI is helping the researchers. So this is what we are learning today, and this is what we have to learn all throughout next 5 years or next 10 years. Again I am saying that AI is in childhood. Within 5 years, AI will rise like anything. It will go to the mountain top. So student, whatever the teachers, whatever the professors, whatever the scientists, whatever the researchers will be coming in these 2 days. Today we have the many keynote speeches, madam has said something. Again we have some speakers which is based on the AI. So all the students, you please keep listening, you keep please laser focused whatever the speakers are telling about the AI. And I promise and I must and I'm hell-bent in that something you will get, and that will be very fruitful, that will be very beneficial for you regarding the upcoming research, regarding the upcoming studies. Now the document of the degree, that is the degree what you are earning all throughout the 4 years, that is not an essential, that has become an optional. The current research have already told you that 70% in the US market, you have seen that there is a drop of 7% unemployment in the US market. Drop of 7%. Previously it was some percentage were there. Right now I have heard that there is a drop in the employment rate on the US market. Then what is going to be in India, and what is the Asian countries, and what are the European countries? Right now we have the European deals, that is based upon the AI. That is based upon the AI. So AI is the current trend, AI is the talk of the town, AI is essential AI has prioritized everything. So that's why this is, I'm the man of, science, basic science, but still I took an interest in madam's research, and I was hearing about the AI empowered PCM engineering. And really, the AI is helping the researchers a lot. Thank you so much for hearing me, and please, all the students, after our speech, you please prepare a note on that and ask some questions. I'm again requesting everyone, if you're sitting here, if your body is only here, then it's alright. But keep your body and mind entangled, because the things which are going, that's very, very important for you. Okay? Thank you so much. Thank you so much.
Thank you, sir. Kunal, online session is ready. Please connect it. So nowadays every field, every section is depending on the AI. I'm the literature lover, but then also I'm totally depending on the AI. That is all. It will take 2 minutes times to join this online session.
अरे इधर आइए, पहले सर का प्रेजेंटेशन अब देखिए, जो ज्वाइन किए हैं उधर क्या कर रहे हैं। नहीं तो सर का कनेक्ट नहीं हुआ है, कनेक्ट नहीं हुआ इसीलिए ना आपको आइए।
कुणाल तू अपना माइक ऑन करो, उधर से ऑफ हो जाएगा। नहीं, अभी ऑप्शन नहीं दे रहा सर। फर्स्ट नो
तुम्हारा कैमरा ऑन है?
नीचे से भी नहीं कर रहा तुम्हारे से
उसको चेंज करना पड़ेगा
हाँ, उसको वहीं से
माइक पे क्लिक
माइक पे
ऑडियो में चेंज होगा देखिए
सर,
वहाँ पे
ठीक
ऑप्शन
है सर, आप स्टार्ट कर दीजिए।
Sir, I will start. I will start. Okay, I cannot hear you, but I can start now.
हम चैट में भी
Okay, thank you very much.
चैट कर लीजिए।
हाँ ठीक है. Okay, okay. Thank you. Thank you. Thank you. Okay.
माइक में प्रॉब्लम होगा।
ये नहीं होगा ऊपर वाला ही।
बेटा मेरे को थोड़ा लिख दो ना। एक मोबाइल में लिंक ज्वाइन कर दो, तुरंत हो जाएगा। तब तक तुम इसको
वो
रिसेट
नीचे म्यूट है बेटा, उसको अनम्यूट करो।
अनम्यूट ही है सर। देखिए आराम से नीचे बच्चे हैं, उसको खाली लिंक बोलिए ना।
म्यूट में नहीं है।
इसको लगा दो ना इसके सबसे काम कर रही है। आप देखो तो आप आ गया होगा।
Scientific progress. Hello. Good afternoon. Good afternoon.
हाँ, good afternoon sir, we are listening you sir, you can please continue.
Okay. Moving forward, artificial intelligence research evolves through both cumulative scientific progress and inspiration from the intelligence, combining knowledge and sharing of researchers. Artificial intelligence is the new electricity. This has been quoted by Mr. Andrews, and then by Mr. Bennis. The factory of the future will have only two employees, that is a human or a dog and a dog. The human will be there to feed the dog, and the dog will be there to keep the humans from touching the equipment. That is, no intervention, human intervention would be required in the future of manufacturing or the life itself. Moving forward, इसको ये गायब नहीं हो सकता, यहाँ से ये गायब हो गया। ये कैसे जाएगा? Just a moment, I'm facing some issues. Okay, coming now to the outline of this particular presentation. I have divided this particular presentation into introduction to AI in manufacturing, then the systems related to AI in manufacturing, the processes related to AI in manufacturing, the quality aspects of manufacturing with AI in consideration, assembly and disassembly with AI in consideration, then case studies, certain case studies and the future direction. Next case study. Okay. Coming now to the early evolution of artificial intelligence, AI has evolved along two major approaches, that is the model-based symbolic approaches and the connectionist data-driven methods. Symbolic AI uses human-defined rules and symbols, and the connectionist AI is inspired by the human brain, which works around the neural networks, which is what our brain is made of, comprises of. Looking at the history of the evolution of artificial intelligence, this can easily be segregated into three parts, that is AI infancy, then the development related to model-based systems, and followed by development related to data-driven systems. In the AI infancy stage, that is in the 1960s or 50s or 60s, Dynamic programming in 1954 was given by Bellman. Decision tree based systems were proposed by in 1963. Then Dartmouth workshop in 1956 was a big event. And then perceptron based systems were proposed in 1957. And the Lisp language, which is the mother of AI based programming languages, was proposed in 1958. And then came the AI Winter Conference, the first AI Winter Conference, somewhere around 1968. Okay. Then comes the model-based development of the model-based systems, that is the genetic algorithm in 1975, expert systems in 1976, back propagation in 1986, and followed by the second AI Winter Conference. Whereafter, the CNN-based model was proposed or worked upon by Lee Kun in 1989, vector support machine-based systems in 1995, and short-term memory in 1995. Then a very popular algorithm was proposed in 2001, that is random forest, and then followed by ImageNet in 2006. And finally, deep learning algorithm was proposed in 2012. Thereafter, transformer in 2017 and generative learning in 2014 by Goodfellow. And then comes in 2020, we have denoising diffusion algorithm by Ho in 2020, and followed by LLMs and ChatGPT by OpenAI in 2022. So this is the historical perspective. From the historical perspective, the evolution of AI-based technologies, from AI infancy to model-based systems to data-driven systems, and we are now post in almost 2026, wherein we are seeing a lot of on a daily basis, we are seeing new technologies being proposed, and systems being developed, services being made available from the US to China and even in India. Then comes the part of AI-assisted production system design and planning. Now, why is AI required in production system design and planning? Is because over the period of time, the production systems have become very complex and need some more support. Automation, simple automation is not able to cope up with the complexity of these systems. So AI-assisted production systems need to be designed or are being designed. Then inspiration has to be taken from AI research. Then system modeling with constraints wherever are there. I mean, in case you have system modeling, but a lot of constraints are there, then AI is required. And then optimization in operations, if it has to be done, then AI-assisted optimization needs to be done. If you look at the alongside figure in this particular slide, you will note that there are four basic operations, that is system design, system modeling, process system integration, and planning and scheduling. The major tools involved in developing or working with these systems are knowledge-based systems and search programs, which are a part of the model-based AI systems. And then on the right-hand side, you have supervised and unsupervised learning and reinforced learning, which is a data-driven based system. I will move forward from this. Coming now to design of production systems from ontologies of the GNN model, that is graph neural networks. Okay, this is what basically looks like. The figure 6, which is, I don't know if it is very clear to you, represents a GN representation of a manufacturing system, which involves the latent features, stacking layers, and node features. And then OWL in additive manufacturing in figure 5, you can see OWL in additive manufacturing, which involves the phenomena, the material and interaction between things, model, physical systems, additive processes, abstract characteristics, process signature, model elements, physical properties, and the interaction in between, so as to be able to give you additive manufacturing systems with AI embedded in it. Moving forward, then comes the design synthesis part involving AI. Human-centered design remains the essential aspect of the production system synthesis with AI-driven simulation, data analytics and visualization, providing early feedback and learning from partial design, that is GNN-based system modeling, which we have talked in the earlier slide. And then digital twin is another very important keyword, which is now very talk of the town, let's say you can call it. So digital twin enable continuous bi-directional interaction between virtual models and physical production systems, supporting high fidelity simulation, design validation, life cycle engineering, and self-improvement by updating the models in real production with real production data. Now, in the figure alongside, figure 7 is an example of the communication between the digital twin and the physical system. Digital twin you can see on the top and real system at the bottom, and in between you can see there is a learning agent, there is a scenario generation module, there is something called monitoring, anomaly detection, learning, and then interaction between them. Observations are passed on to from the real systems are passed on to the monitoring system, which go into the anomaly detection module that go into learning, and thereafter the digital twin is updated. And whatever scenario generation, in fact, it can also certain scenario generation can also be done in this. Certain feedback loops are also there, and control inputs are also there. Moving on. Coming now to production planning and scheduling, as PPS they call it. In certain organization it is also called production planning and control. But the currently famous word or in trend word is PPS, that is production planning and scheduling. PPS involves a strategic, tactical and operational decision to meet production targets. It can be viewed as an order competing for limited resources in a dynamic production system. That is, the resources are limited and the orders are more. So you have to cut the cost down such that you are able to complete the orders in time with the limited resources that are there. This is the scenario in modern production systems. Coming now to solution requires time-linked action across multiple resources with satisfying constraints on cost, time, quality, and energy resources. Now, these are the actual constraints. Due to combination, complexity, and information symmetry, the real world PPS problems are computationally challenging to solve. Hence, the requirement of AI-based systems. So, these are the challenges related to PPS. Moving forward. So, what is the AI's approach to PPS? Okay, what is the AI's approach to PPS? Challenges of PPS. From mathematical programming to search, the traditional PPS relied on mathematical programming, while AI introduced constrained programming, that is CP it's called, and search-based methods that flexibly handle hard and soft constraints, enabling adaptability and the incremental scheduling solutions. Coming now to search and meta-heuristics, the techniques such as local search, taboo search, simulated annealing, and large neighborhood searches are widely used to solve complex problems, combinational PPS problems, often in hybrid forms with optimization models. Coming now to the need for learning-based methods. That is, the system also has to learn from its experience. That is, PPS is dynamic and time critical, requires online decisions with accurate system models and simulations that may be unavailable in the computation or may also be computationally very expensive. Coming now to the role of the machine learning, because AI and machine learning always go hand in hand. That is ML and DL, that is machine learning and deep learning supports support for forecasting, that is demand and lead time, process modeling for event data, and surrogate modeling, enabling fast evaluation of schedules and real-time decision making, often integrated within the digital twin itself. So again, we have the digital twin here. Okay, a lot of people are working on digital twins. There is a huge demand in terms of jobs also, or also in terms of startups based on digital twins. Any cyber physical systems, let's say even a heat exchanger, you can build a digital twin around a heat exchanger, and you can simulate what is going inside the digital. For example, a heat exchanger, which is one of the simplest things to make a digital twin of, because it doesn't require any moving parts. The only factors that are there are the flow of the hotter liquid and the cooler liquid changing with time, and some fouling that is taking place, some corrosion that may be taking place. Only very limited factors that it is easier to build such a system, digital twin of such a system. Moving on. Let me not get into the digital twin part too much. Moving on. AI in process modeling, management and optimization. That is, the process has to be modeled. Whatever process, the manufacturing process that you are applying to it, that has to be modeled. Then the management part of it, and finally the optimization. Manufacturing process are the core step in transforming raw material into finished products. Ensuring efficient and anomaly-free process is always central to manufacturing goals. Third point, growing process complexity makes traditional domain knowledge-based modeling and optimization insufficient, because of the complexity that has now come in manufacturing. All the old systems are unable to take the load and slow down the process. The actual system may be able to generate, let's say you are making something like mass production, assembling something in mass production. It is able to speed up, but you are not able to model the process itself. And the complexity involved is so much that without AI or machine learning or these advanced systems, you cannot. It is more like, I can say it's more like you are having an aircraft, okay, and you are because you don't have a license to fly, you don't know how to fly it. You are not flying it, you are running it on the road. So without AI, such advanced for manufacturing processes or machines will not be able to deliver their best. Moving on, AI techniques support process modeling and parameter optimization, enabling improved process and in complex manufacturing systems. And alongside we have a figure 8, which is the AI research for process design, modeling and optimization. So these are the processes, that is process design, modeling evaluation, process control and parameter optimization. And what are the tools, AI tools that I use? That is modeling side way, model-based systems may we have search and programming, and a knowledge-based system. Again, on the left-hand side, right-hand side, we have reinforced learning and supervised learning, and how they interact and what is going into what, such that you are able to deliver advanced process modeling, manage the system and optimize the system. The audience can, I'll be sharing this particular slide, so the audience can definitely go through it later on. Next being the process design itself. That's this slide is all about model-based techniques used in process design, then the hybrid AI-based approaches, then the integration of data-driven based AI systems, and then challenges in industry and industry readiness. So model-based techniques which were there earlier, that is the expert systems, people who have around 30 years of experience will know what is expert system. People have been working on expert systems earlier, but these are now kind of old and are generally not used, or are certain other advanced systems are built on top of the expert systems. That is expert system and evolutionary algorithms to improve process planning, decision making, and efficiency. Model-based techniques were used. Then the hybrid AI approaches came into picture, and neural networks, fuzzy logic, and rule-based systems which enabled these processes, and digitization of the process plan was possible. Then comes the next part, that is the integration of the data-driven and the model-based AI system. That is, now has come the data-driven system in which the hybrid model enhances production planning efficiency and supporting automation and Industry 4.0 adoption despite its training and machinery challenges. So India as such has lagged in adoption of Industry 4.0 significantly. In fact, we almost missed the bus in Industry 3.0, and we are now at the threshold of adoption of 4.0. And in fact, we are also already lagging behind, and the industry is already working around or proposing Industry 5.0. So we are again one generation behind, but we need a lot of work to be done by the industry, by the people, by the young generation of India, such that these systems are aware. They are aware of these systems. They can work with these systems, even if the systems are, let's say, imported or developed in India. But you need hands-on people. People have to who can work on these systems. Moving forward, challenges in industry readiness. This is what I was talking about. That is, adoption is limited by machinery constraints, worker training gaps, and integration hurdles in Industry 4.0. Because of the reason is being that Industry 3.0, we already have missed that bus. Very few industries were able to adopt 3.0, and we had to jump to 4.0. And again, 4.0 is already old. Moving forward. Process modeling and evaluation. So PSPP and process dynamic modeling, that is AI predicts the final part properties. Okay. Then moving on, the high prediction accuracy. That is, neural networks can achieve low prediction, have low errors. Just a moment, I have a call. It's an important call. Hello.
Say yes. Sorry, asking.
Process optimization and customization, and here is an example of how energy prediction of a CNC machining with ML can be done. Moving forward, process optimization. So process variation management, predictive modeling, integrated control, and enhancing quality and efficiency. Just a moment. Hello. अरे बाबा माइक प्लीज नहीं है. Some technical issue and I got logged out. I am continuing now. Share करना है पर okay हाँ ये
Login to another one. You have to log in, no? Go to the browser session started. We have
ऑटोमेटिक जा रहा है ऊपर ऑटोमेटिक जा रहा है ठीक 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 Okay, I hope you can hear me. Okay, moving forward. Then comes the other aspect of manufacturing, that is quality assurance and maintenance, and involvement of you have to allow me to share the page. It says host isn't allowing sharing for this meeting. Sharing को turn on करना पड़ेगा इसका. हाँ ठीक है ओके.
This meeting is being recorded.
Moving forward, we are coming to AI in quality assurance and maintenance. So hybrid AI frameworks have to be developed, which can also be data driven and also model driven also, both. In model based AI systems, physically in physics information has to be there, feature based methods. Data driven AI ensures reliability and interpretability. Coming now to defect and wear diagnosis, AI enables surface defect detection, tool wear monitoring, and structural fault identification using signal processing and learning based models. Coming to another great aspect is predictive maintenance, that is advanced AI supports remaining useful life RUL prediction through degradation models, state space methods, and probabilistic learning. And then next generation AI methods will adopt deep learning, federated learning, and physics consistent AI, which improves robustness under data imbalance. In case the data is not sufficient, it can still work, and limited failure data, even if limited failure data is available. If you look at the right hand side, you can see a schematic diagram of the interaction when AI is used for quality assurance. Let's say, for example, surface defect detection, tool wear detection, and structural fault and RUL predictions. What are the knowledge and what are the AI systems that are involved in when these predictions have to be made? That is feature-based system, physics knowledge-based system, generative learning, and supervised learning. And what are the technologies that are there? Moving forward, AI enhanced condition monitoring. That is the condition of the machine itself. Okay, not the product. In the earlier slide, we were talking about surface defect, tool wear, and things like that. We are talking about AI enhanced condition monitoring. That is condition of the machine, the manufacturing machine itself. That is automation when automation inspection is there. Online condition monitoring, replacing slow moving stuff, human inspection, minimizing human inspection, and minimizing delay in defect detection, image driven defect analysis when it is used. That is model based system like SIFT, SURF, that captures local pixel variation to compare with what. And then if you are using deep learning based systems, then CNN complex learn complex non-handcraft features directly from the data, enabling accurate detection. Now, if you look at the example of enhanced AI enhanced condition monitoring, you can look at this particular system that is there. That is UNIT for defect segmentation for automated learning. Moving forward. Machine remaining life prognosis. Okay. Now, if a certain machine is there, it may be a manufacturing system, or it may even be a product. It may be a product. So, what is the purpose of prognosis? Is that we have to know the remaining useful life. It is written live, but I think it's a correction. Live. Okay, prediction. It can be estimated using AI-based systems. Now, what are the systems that can be there? AI-based system. It may be a model-based degradation modeling system. That is physical laws that take into consideration the wear and tear that happens with usage and with time. And then if you are using hybrid-based approaches which combines the physics-based degradation model and the data-driven parameters so as to evaluate the remaining useful life with more accuracy and more robustness. In the figure that is there in this particular slide, it is a battery electric vehicle is there, and then the battery part of it is being looked at how, that is how much useful life is there, and observed battery data can be checked online in present scenario, and then various other predictions can be done based on the past usage of a certain car. What is the trajectory of the battery degradation that would be there? And there are different models. Based on different models, predictions can be made. If you are going along the same line, this is the line that it will take. If more use of the same electric car is done, the model would die out faster or later. Moving forward. Now, the role of AI in automated flexible assembly and disassembly. That is, wherein we have to assemble and disassemble parts using AI. So, intelligent assembly planning can be done using AI, which is the order in which a part may be assembled. Okay. Then AI-enabled robotics, if you use, there is a term called not just robots but also cobots. That is the next part of it. That is human-robot collaboration. That is cobots. That is, the difference between a robot and a cobot is that a robot, if it is moving in if it has been given a certain path, even if you stop it will push you and will push you. But a cobot will stop wherever you have tried to stop it and will continue from that point onwards. So it is aware of it. What is the difference between a robot and a cobot is that a robot is unaware of its surroundings and a cobot is aware of its surroundings. Then comes the future ready system, that is AI driven, reconfigurable, self-optimizing assembly system for efficient and sustainable manufacturing. Alongside on the right hand side you can see figure 14, which is AI related research to automated assembly and disassembly. What are the applications? That is assembly planning that can be done, robot grasping that can be done, robot disassembly can also be done, and then human robot collaboration can be done. That is, cobots can also work in this environment. Okay, moving forward. AI for symbiotic human-robot collaboration. Now we are focusing on the cobot part of it. Okay, that is, it is flexible and mass customization can be done. Okay, then AI-based human action understanding. If you are in front of a robot and it has the eyes and because it is aware of its surroundings, so it can understand what you want to do. It can follow your movement if you want, something like that. Then comes the proactive in robot collaboration. That is, RNN-based human trajectory prediction allows robots to anticipate movements, synchronize with workers, and enable proactive part tool handover. The example of human-robot collaboration can be seen in this particular figure. Okay, in this figure, and moving forward. Because I'll be sharing, I'm going faster, and we are also short of time, and we have already lost some time due to some technical issues. Moving forward, what is the future of AI-based assembly and disassembly? That is, the first thing being beyond current payload limits. That is, the future AI research must enable high payload robotic assembly, that you can handle more heavier parts requiring advanced cognitive skills and enhanced human robot safety. Okay. Then the second part being the AI enhanced human support system, that is intelligent exoskeleton systems. I am sure most of you may have seen Hollywood movies wherein a man gets into a robot. That is basically called an exoskeleton. Okay. What you can see in a figure is also figure 16 alongside. You can also see an exoskeleton wherein the human is able to lift 100 times his weight because of the reason that an exoskeleton is there, and it helps in picking up the heavier parts of it. Okay, moving forward, intelligent exoskeleton will leverage AI for intent detection, human state estimation, what is the human fatigue level, and all these things are also possible. Just as I said, that in cobots are aware of their surroundings, and adaptive kinematic control to form symbiotic human machine systems. Coming now to adaptive object handling, that is AI enables robust robotic object perception, manipulation, and in process adaptivity, essential for real world assembly and disassembly tasks, and reduced programming efforts, that is cognitive AI capabilities, that is task recognition, automatic control, parameter generation. I'm sure some of you may have seen videos in which a person is there, and then he holds the arm of the robot and gives it a certain movement, and thereafter the robot starts copying that movement. So there is no need to program these robots, new robots, the cobots that are there. They are aware of their surroundings, and if you put them in that mode, you just record what your movement is and then repeat thereafter. So that is even possible. And then comes the industrial case study. That is the vision of AI in manufacturing. The ultimate goal is to translate advanced AI techniques to these manufacturing systems such that they can be made autonomous, that is independent of human involvement. Just if you remember the first slide, we were talking about a factory having only a man and a dog, and the man is supposed to just feed the dog, and the dog is supposed to just keep the man away from the machine. So autonomous, without any intervention. Adaptive, that is, if a scenario changes, then the robot would itself, or the manufacturing system itself, will adapt. Then comes the intelligence across the entire production life cycle. Then comes the shift towards mass customization, that is which increases task variety and the error risk in assembly, highlighting the need for to support human workers and ensure quality and enable timely error detection in complex operations. Germany is quite ahead. In fact, China is also quite ahead, but Germany is also doing a great job. And Germany Research Center for Artificial Intelligence, DFAI, and Hitachi have implemented an AI-driven human activity recognition using multimodal sensor fusion to monitor and enhance worker safety and productivity in industrial environment. That is, they are working on advancing the current state of cobots, collaborative robots, in a production or a manufacturing environment. Moving forward, alongside figure, you can see the flowchart of AI-based human activity recognition system. Okay, moving forward. Coming now to another slide on industrial case study, that is sensor setup and deep learning and worker assistant and industrial impact, how they are there. that is sensor can be done. Moving forward, there is a YouTube link also. I will be sharing this particular slide so you can go ahead and the system will be able to judge what we are doing. Okay. So, coming now to almost the last slide, yeah, it's the last slide. Challenges and future direction. So, we are improving AI performance, robustness, and trustworthiness while efficiently managing the rapidly growing volume of manufacturing data to enable actionable insights in smart manufacturing. That is, now first is unsupervised learning for unlabeled data. Secondly, being integrating physics with AI. What is the physics behind a certain thing that is going on, and AI integrating it with that. Okay. Then comes embedded safety constraint. Robots have been known to kill people also. Okay. So you have to embed the safety aspects of inside the robots or the manufacturing system. That is, the manufacturing system is aware of its surroundings. Okay. Then comes the learning from human demonstration. I have already spoken for certain robots or cobots being there, and human arm can guide it in a certain mode, guide it. These are the things that you have to do, pick and place and this and that, even paint in a certain direction and things like that. And thereafter start the robot, and the robot will move till you give another command to change the operation. Okay. So that is there. This technology is already there. Only refinement in these technologies are being done. The basic technology is already there. And coming now to adopting generative AI in manufacturing. That is LLM in manufacturing. Okay. Large language models in manufacturing. So if that data would be there, once that data is there, even the manufacturing system would be able to know what to do in a certain scenario. Let's say a tool wear has taken place and it is aware of it, and let's say half of the tool wear has already taken place. Example I am giving, half of the tool wear has already taken place, and it is aware that depending on the workload that is there in the next 2 days, and the certain tool will last for only 2 days, and the ordering time and the availability time and the availability of the tool at the machine will take 2 days. It will order the tool to be sent to his workstation directly. The machine will be able to do it directly. Again, remember what was said in the first slide. Future of manufacturing would be a man and a dog, wherein the work of the man is to feed the dog, and the dog will only make sure that the man doesn't touch the manufacturing system. Thank you very much. I am sorry I had to face some issues with Amila. Yeah. I shut down the video because maybe it was taking up a lot of data and technical issues were there. So that is all for the day. Will be sharing this particular slide with you all. Thank you very much.
Thank you, sir.
Any questions you may have, ask now, or even you can
Any student, if you
the
have
chat
some
box
questions. Any
I will
student
try
if you
to
have some
respond to
questions
it as much as I can.
from Sanjay sir regarding whatever the presentation sir has given to you, and if you have some queries you can ask, or if not then sir, I may be allowed to ask one question, sir.
Hello, am I audible, sir?
Yes, tell me.
Sir, you just told us that is the AI performance, robustness, trustworthiness, opportunity, challenges, future directions. Just one thing, just want to know that at the last you said that there were only 2 persons in the industry, one the dog, another the people. And the dog will be looking after all the automation part of the industry, all the machining part of the industry, and the dog will be feeling hungry. The people or the person will feeding the dog. Then is this the real, or is there all the real?
Yes, this is a real scenario. It is going to happen in due course. Obviously, it will. There will be a lot of challenges related to this. People will talk about unemployment. What will happen to that? Maybe we will all come under the food. We will be given salaries for just being feeding the dog. You can say that.
Thank you so much, sir. Thank you for your very kind speech and your brief details about the AI and its percolation in the current research and whatever the things we have done with. So thank you so much, everyone, from the behalf of the college and from the behalf of the student and the faculty members of RVSCT. I'm really honored and humbled to have yourself in the RVSCT for the IEEE conference. Thank you so much. Thank you, sir.
Thank you very much. I appreciate the opportunity to interact with RVS College again. To thank you to your HOD and your principal both. Thank you very much.